Hi everyone and welcome to my channel. Today my topic is Circle Theorem. In this video I plan to cover those laws that pertain to angles formed in a circle. Now there are many laws but I plan to cover about 9 of them, and I want to do a few detailed questions to show you exactly how we break it down. This topic is usually done in Form 4 or Form 5 and it's done in math. So please stay tuned to see what I have in store. So there are about 9 laws that I plan to cover in this video, and this is the first one. If I had 2 points on the circumference, say A and B like this, going up to the center to form a radius here and another one here, an angle is obviously formed here. Now what if these same 2 points A and B went up to a common point called C, right? Now this line here is now called a chord, right? It's not a radius nor is it a diameter, and similarly the same thing for this line, it's also a chord. So what they're saying in this rule is that the angle formed at the center would be twice the angle formed at the circumference. Now I just want to take it a little further. And what if I went up to another point here, D? So say A went to D like that, and B went to D like that also. Then this angle here will also be E, and this here will also be 2E, right? So this is my first rule. Now the second rule says angles in the same segment are equal. So again, let's say this point here is A and this point here is B. Now if I draw a dotted line here, this again will be a chord. This chord will separate the circle into 2 segments. This one is called the major segment and this one here is called the minor segment. What they're saying in this law is that angles in the same segments are equal. So A and B went up to a point here, say C. A and B went up to another point here, D, and say A and B went up to 50 million points, again on this side of the segment. All the angles formed here will be the same. Now similarly, if A and B went down this way, in this segment, another angle would be formed, but all of them will again be the same. Whatever angle is this one will be the same here, right? So this is my second rule. Now my third rule says the angles in the semicircle is 90 degrees. Now how do we do this? Well, we create a semicircle. A semicircle is done by simply dividing the circle into half, and to do that we need to pass through the center. So if we went up to a random point, let's call it again C, the angle formed here must be 90 degrees. If we went up here to another point like that, D, again another 90. And similarly, if we went in the other semicircle, this other part here, again I'll get 90 degrees, 90 degrees, and so on. So this is the third rule. Now let's move on to the fourth rule. The fourth rule says opposite angles in a cyclic quadrilateral add up to 180. Now a cyclic quadrilateral is a quadrilateral where all the edges, the 4 edges like this, touch the circle. That is a cyclic quadrilateral. So once this is happening, what you'll notice is that these opposite angles are supplementary, or they add up to 180. So if I know how much this one is, I can figure out this one by simply taking 180 and minus it, whatever that is. And that's the same rule that will apply here as well. So this is the fourth rule. Now let's move on to the fifth rule. The fifth rule, similar again, cyclic quadrilaterals, but now we deal with exterior angles. How are these exterior angles formed? Simple. It's simply by taking these 4 points here, A, B, C, D, and extending out the line. When I extend out these lines here, I get an exterior angle. This exterior angle here, this green one, is the same as the interior opposite. So this is the interior to the green angle. This blue angle here is the interior. However, the interior opposite is this side here. So say this was 60 degrees, then this angle here will also be 60 degrees. And why do we say? Because exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. So now let's move on to the sixth rule. This rule says the perpendicular from the center to the chord bisects the chord. So say we had a chord here, A, B again, right? So a chord is any line going through the circle that does not pass through the center, right? This is the center here, right? Now what will happen is if I drew a line from this center to the chord, it will bisect at 90 and it will also cut this line in half. right? So, well, that's what bisect means, right? It means cut it in half, right? So now let's move on to the seventh rule. The seventh rule here says that the angle between the tangent and the radius is 90 degrees. Now a tangent is a line just like this, just brushing against the circle just one time. That is a tangent. Now when we have a tangent like this and it touches a radius, this is a radius here, then the angle formed here is 90 degrees. And that is what this rule says. The angle between the tangent and the radius is 90 degrees. Now let's move on to rule number 8. Tangents from a point outside a circle are equal in length, right? So now, let's say this point here is A and this point here is B. This is the point where this tangent cuts the circle and B is the point where this tangent cuts the circle. But say these two tangents went off like this and they end up intersecting at a point X. What will happen is that this distance here, AX, is the same as BX. So what they're saying is tangents from the outside, from a point outside of a circle are equal. So this is rule 8. And now lastly, rule 9 now. This is an interesting one. Alternate segment theorem. So what this is saying is that if we had a tangent like this and a triangle in here, this outside angle here, this exterior angle here is equal to the interior opposite angle here. So it's similar to the cyclic quadrilateral one, this one here, but we're dealing with a triangle now, right? So how I like to remember it is that this angle B is formed by this tangent here and this side of the triangle, right? So for me to get the other angle that is B, I will not use this side that I'm using to make B. I will use the next side, right here, that touches the tangent as well as the third side of the triangle. I hope that makes sense for you. But yes, that is how I tend to remember. So similarly, the angle here, A, right, is formed by these two sides, these two lines. So I'm not going to use this line. I'm going to use this line here and the third line for the triangle, and this is A. So this angle here and this angle here will be the same. And the rule here is that alternate segment theorem, which means that the exterior angle formed by a tangent touching a chord is equal to the interior opposite angle within that triangle. Another way of saying this rule for law 9, is the angle between a tangent to a circle and a chord at the point of contact is equal to the angle in the alternate segment of the circle. So again, this is a tangent, this red line here, well this green line now that I'm drawing, right? So the angle formed here at the point of contact, that is the angle B that I had here before, right, is equal to the angle in the alternate segment of the circle. So that will be the alternate segment here, right? So that angle there. So now let me move on to do a couple questions so that I can go through to make sure that you all understand. It's my first question, and it says here, we have a diagram and it just says find x and y. Now x is here and y is here, right? So if I were to look at x, the angle formed here at x, I'm seeing it's within a triangle ABO. Now this is a radius and this is also a radius. So which means that this is actually an isosceles triangle. So here will be 37 also. So then x will simply be 180 degrees minus 37 minus 37. And that would go to be 106 degrees, and that is because the angles in an isosceles triangle would be the same here. They have two angles that are the same. So therefore this angle here would have to be 180 minus 37 minus 37. So you have to make sure and document that. This could be the reasoning. Two angles in an isosceles triangle are equal, and you could also list ABO is the isosceles triangle. So now let's move on to find y. Find y, what we have to do is I'd have to look at the other rule here, right? So that rule says that I have a diameter here, BD, and it goes up to a point C. So then this means that this angle in a semicircle are 90 degrees. So then I will write y is equal to 90 degrees. Sorry, this angle here is 90 degrees. So y would be 180 degrees minus 49 degrees minus 90, right? And that works out to be 41 degrees. And that's why, because angles in a semicircle are 90 degrees. So that takes me to the end of example 1. Now let me move on to example 2. Example 2 now, part A says find the angle DAC. Now if we look at this angle, we'll see that is actually the angle from here, D to A to C. Now this is an easy angle to find. I have 2 points on the circumference called D and C, and they actually go up to this point B, may form the angle 46, and they go up to another point A, which will also form the angle 46. So this angle is 46 degrees, and that's because angles in the same segment. You make sure that you have your reasoning why it is you put in the answer. You don't just put 46 degrees and you leave it like that, right? So you make sure and put that. Now, my next part now says find DAC. To find DAC now, sorry, not DAC, DBA. DBA is actually here. Now, what we can see is that A to C is actually a diameter and it goes up to the point B. So therefore, this would have to be 90 degrees. This angle here will have to be 90 degrees because angles in a semicircle are 90 degrees. So DBA will actually be 90 degrees minus 46 degrees. So that works out to be 44 degrees. And again, you put your reasoning. The angles in a semicircle are right angles. Now, let's move on to the last part. The last part says we need to find angle. The third part now says we need to find angle BCE. So B to C to E is actually here, right? This angle here. Now this one, I may have to use the rule with exterior angles in a cyclic quadrilateral. So this exterior angle will actually be equal to the interior opposite. So it will actually be equal. This is the interior here, and the opposite for this will be these two. So BCE will actually be 46 degrees plus 28 degrees, and that works out to be 74 degrees. So this angle here will be 74, and as well this angle here will also be 74 degrees. And what's the reason for that? Again, this is my reason. Exterior angle in a cyclic quadrilateral is equal to the interior opposite angle. So now let me move on to example 3. Example 3, they ask us to find x and y. Now to find that, now I'm seeing a nice simple rule here. X will actually be just double the angle of 70. So x will be 70 by 2, which is 140 degrees. And the reason angles at the center is twice the angle at the circumference. Now to find angle y now, what I do, y now is actually down here. This is a cyclic quadrilateral here, and 70 and y will have to add it to 180. So because angles in a cyclic quadrilateral are supplementary, so 180 minus 70 is 110, and the reason would be angles in a cyclic quadrilateral are opposite angles in a cyclic quadrilateral are supplementary. So this is my reasoning here. So now let me move on to example 4. Example 4, we are asked to find ABC. Where is ABC? ABC is actually this angle here. Now for me to find this, I'm seeing this tangent here, and I'm seeing this angle here is 40 degrees. And according to the rule, angles in alternate segment theorem, the alternate segment theorem says that this angle here will be equal to this angle here. So this angle is actually 48 degrees. So we put our reason. I have here is alternate segment theorem, or the angle between the tangent and the point of contact is equal to the angle in the alternate segment of that circle. So now let me move on to part 2. They're asking us for AOC. So that's actually here. Now that's a nice angle to find. That's actually 48 degrees multiplied by 2. And that's because of the angles at the center. So I'll just write that up. This is what we have. Now you have to make sure that you have your explanation, right? You can't just have 96 degrees. Also, one thing you need to make sure that you have is make sure that all your angles are marked with a degree symbol. Now let's move on to part 3. Now part 3 says now to find BCD. So B to C to D is actually this outside angle here, right? Now for me to get that, I could actually fill in some other values. Now since I have 96 here, I could work out the angles here, because this OAC is actually an isosceles triangle. So this angle here will have to be 42 degrees because these two will have to add up to 84. So now, if I just need this angle here, this is a straight line, so all of these will add up to 180. So then this angle will actually be 180 degrees. I'll do the work in here. Minus 48 minus 42 minus 26. And that works out to be, these angles in a straight line add up to 180 degrees. So that's the work in there. So that piece is 64 degrees. Now let's move on to part 4. They ask for VAC. So VAC is actually where? Okay, to locate VAC first. So V to A to C is this whole angle here, right? Now I know that here is 48, and I also know that these two angles are 42 and 26. So if I look at triangle ABC, I could simply work out that, get VAC by simply taking 180. 48 minus 26 minus 42. Now it came from here, 48, 26, 42. So then I will get this angle here, and that works out to be 64 degrees. Of course, the reason for that is angles in a triangle add up to 180 degrees. So now, let's move on. OAC. OAC is actually O to A to C, which is actually 42 degrees. So we know this already, and that's because of it's being an isosceles triangle. So it's an isosceles triangle, so angle OCA will be equal to OAC. Now the last part now is OAB. OAB is actually O to A to B. So that's this little piece here. So that will actually be 64 degrees minus 42 degrees. So 64 minus 42 is 22 degrees. So that is my final answer, and the reason for that would be angle here is actually 64 degrees. So 64 minus 42 will actually be 22 degrees. So that, everyone, takes me to the end of my video. I do hope that this video has shed some light into this topic and has made it more understandable for you. So please feel free to share, subscribe, and of course like. Thanks guys.